Welcome to another GCBASIC demonstration. This one is again with the AVR DX series we're building because we're enabling AVR DX, and we're talking about graphical LCDs and how they operate. GLCDs. I'm using software, TWI or IC squared, and we'll have a look through it. Let's have a look. So what am I using here? I'm using a C Nano board. Happens to be a 4809, but it will work on any of the range. Essentially, I've got it hooked up. I've hooked up a GLCD. It's got two wires connected to it because it's using two wire protocols, or I2C, and it's got a data line and a clock, and I've got some pull-up resistors, and you're going to see all that. Okay, where it connects to, it doesn't really matter because we're using software SPI, so we can sort of choose which pins we use. But you've got to be careful that you don't use the same pins as the debug interface. I did that earlier on, and of course it doesn't work. So what does it look like when it's operating? We'll have a quick look at that, and then we'll just reset everything and go back. So look, what we're seeing here is on the left, the AVR board. It's the C Nano 4809 and a GLCD connected through a yellow and blue wire to the data connections here. And that's connected to a clock line and a data line. And as you can see, it is drawing circles, text, strings, numbers, etc. Okay. It does lots of primitives that you can build your own solutions, but that's it working. It sort of works like that. And what we're going to do is just run through how it all operates very quickly, just a high level view. So what we're going to do is we're going to check a couple of things, but in reverse order. We saw it working, but we're going to see how I walk back through that to make sure I've actually got it connected correctly, to make sure I've got my pull-up resistors. In the previous diagram, we had pull-up resistors. Are they fitted? Can we see the device or devices on the bus? And then I just show those on a serial line. So in order of how I make these things work, I check the serials working, obviously, to make sure that works. And then I do discovery to make sure I can see the device. And then I know it's working to use the GLCD command set. If you don't do that, you're just going to have issues. If you go straight to GLCD, you didn't do the basics. Check serial, check the bus is working, discovery, and then see if it's working. So let's have a look. Let's have a look at what we've got. I've got some demos here. Now, there is a demo. I shall zoom in for you. And that demo is available, it's published, and all it's going to do is going to put some serial on the screen for us. And all it's going to do is going to make sure that you know which serial port you're looking at. So if I just program that, and I'm going to open up in a moment a serial terminal. So function key F5, or press the top right-hand corner to make a program and program it, which it's done. I can just show you that. I'll press function key F5 again. And very quickly, it's compiled up that test program. And all that test program does is send data through to the serial line. And it says here, and I won't go over this many times, the chip is up here specified. Here is two setups for two serial lines. And it's basically sending out the word hardware UART and number 1 and number 3 on these two lines. So at least you know what terminal you're talking to, okay? Let me open up a terminal, function key F9, or you can press function key F4 and select the terminal. I'll put that in your view so you can see it. Here we go. Let me just drag it across. And if I do a rescan, I've got one COM port, and that's that board. And if I press connect, it won't work. Why not? Because on these boards, you need to set something else. You need to set the DTR here. The moment you set that, it says I am operating on UART 3. So we know the serial's working, which is great, because if we know the serial's working, we can go to the next step. Well, in this new set of demos, there's a software discovery, and all it is, it's the same header. It's now got the ports for the I2C, TWI, call it what you like. It's got a data line and a clock line, and I've connected them to port D5 and D4, and that's data and clock respectively. The rest of it is just serial. It says put stuff on the screen. And what it does in the program here, it's the high level code. It says sends I2C start, send a device out. If it recognizes it, put the number on the screen. If not, put a little dash, close the transaction down and stop it. So it's going to go start, send a number. If it gets a response from that device on the bus, just close it down with a stop. So start, send just to close the transaction, stop. And the rest of it is all about displaying stuff on the screen. So if I press function key F5, and we will just see that it's programmed it down here. Down here it's programmed it already. We go back out to the terminal. I'll bring the terminal into view. It's scrolling away quite merrily. Let me just get rid of that for you. Maybe get rid of the settings. It's saying here that there is a device set on address 78 and 79. Look, it's polling the bus. It's seeing there's a number. It goes 78 or something. So I know that there's a GLCD attached to it or a device, and I happen to know it's a GLCD because I looked at it with my eyeball. Okay, so we've done serial worked. We've discovered the device, so we know we've got the pull-ups. Let's look at that for one moment. In here, I've got some volts coming in, 5 volts, and I've got the pull-ups fitted. And those pull-ups need to be fitted on the bus, otherwise the discovery will not work. In the PowerPoint, if we go back to what we were looking at in the PowerPoint, we can see that we had some pull-ups here. Let's just show that on the screen. We had some pull-ups here. Look, on the left, VCC's 5 volts for this device. I've got 2 4K pull-ups, and there's my device responding on that bus. Imperative you have those pull-ups. You could pull it up from the chip itself, but I'm using externals because this is what I do. Let's go back to the program, because now what we've got and we're going to see is we're just going to go into this demonstration program, and in here it's going to draw a load of lines out. It's going to put strings on the screen, etc., etc. The header is exactly the same. Chip, option explicit. Here is the exact same I2C setting that we used previously in the discovery program. Now we're saying include a GLCD. The moment I say that, it now includes a whole series of new commands. I just need to tell it what type it is, and the type here is GLCD type SSD 1306. And the address is 78. We discovered that from the previous program. The rest of this is just putting stuff on the screen. It's numbers and variables. GLCD print, put a string on here. It's called portability demo. Why? Because I run this same program on hundreds of chips, okay? And it's going to put the chip name on the screen, on that little screen for us. And this program is a standard test. I just take it and I just put a header on it for this particular chip, and I just always just run it. So if I run that, we go back to the camera, it will compile it. It takes a bit longer because it's a bigger program. And it's not moving here, as we can see. It's just downloading it. And now it's actually got what we said on it. Look, it said GLCD. I'll do it. I'll reset it. How do I, if I just cut the power to it, does that reset it? I don't think it will, because I'm going to power cycle on this chip, okay? What it's doing here, as you can see where we started, it's putting strings and text, etc. It's also got at 20 megahertz, so we can we'll change the frequency, and it says here GCBASIC Unobium 2024 portability demo on a Mega 4809. Could be any chip, and it's doing it at, as it says on this little screen here, at 20 megahertz. Let's just go back to our program. Have a bit of fun whilst we're here. We're going to change the frequency here to 5. That is a valid frequency for a 4809 when you've got the 20 megahertz chip set up. So what it's doing now, it's just recompiling down the bottom. I'll just show you. It's just recompiling it now, look, and it's just programmed it out of Deskcam. Here's the same, it's just on the reset as I switched out. And it now says it's doing a 5 megahertz, and you can see it is considerably slower. Now, to be quite frank, these AVRs are not fast. Even at 20 megahertz, they're not quick. If you take an LGT from China, a clone of an AVR, it is rapid compared to this, but it does it. Now, this may be faster when we use hardware I2C or TWI. It may be, I don't know. We'll have to wait and see. But I'm just going to revert my program back to 20 megahertz and we'll just reprogram it whilst it's doing it. So in summary, what we've got is an AVR DX chip, software TWI, I2C. To me, they're the same. I've got 2 wires with pull-ups into my GLCD, and I'm now running that back at 20 megahertz. So extremely simple. From that, you can build your own solutions, and there are many different GLCD drivers you can now use if you're using the software SPI software TWI or I2C option. Let me just go back to my slides to make sure I've not missed any messages. Let's have a look at my slide. Well, I wanted to see where Serial was operating. It was. TWI Discovery was shown, and I showed you a working GLCD. The commands are just so simple. I should really show you the commands, I guess, in here. Let's have a look in here in the code. I'll just pull that down so you can see it. I showed you like the print string. That's great. You've got boxes, circles, lines, triangles, filled squares, filled this and filled that. You could use this chip and this approach. There is a 7-inch display I've hooked up earlier this year. Fantastic on LGTs. It should work. It will work on here. It's not, it should, it will work. And in here, you can see we've got filled circles, filled boxes, etc. And they're all documented in the help by pressing function key F1. It will open up the help and show you what the syntax for that particular command is. Relatively simple to do. Pull the screen down. There's a syntax for that. All I did was select the word in the IDE and then away we go. Let's go back to my slides. So there we go. AVR DX using GLCD, pretty simple software. Enjoy.